So today there's a huge centralization of compute on planet Earth. So we have huge data centers owned by around 5 companies.
Hello, innovators, entrepreneurs, and risk takers. Welcome to another episode of Web3 with Sam Kamani podcast. And today, on this podcast episode, I am interviewing Dr. Christian Keller from Acurast. They are building the next layer of decentralized computing that can be used by AI and Web3. So, we talk about all things to do with AI and LLMs and inference as well as decentralized infrastructure, and we touch a bit about on quantum computing as well. But the key thing here is I wanted to interview people who are building at the cutting edge of AI and Web3. And Christian is someone who works in this space at that level. He is going and giving talks at everywhere from MIT to some of the leading places where the top minds in this field gather. So he has the in-depth knowledge as well as he is living and breathing this space day in and day out. Let's learn from him on what they are building, how they're innovating, and where they see this industry going. As always, nothing that we talk about in this podcast episode should be taken as investment or financial advice. And as always, please leave a like, subscribe, and share this episode on your social media after you have finished watching or listening this on whichever platform you are on. With all that out of the way, let's get into it. So, Christian, welcome to the show. I am so looking forward to interviewing you and talking all about Web3 and what you do at Acurast and what you guys are building. But first, to get started, how did you get involved with all things Web3?
So my journey with computers started with video games, as many hackers did. So I fiddle around with how can I modify this game? How can I make it do something else? And from there on, it just was like one big rabbit hole.
Yeah.
And during my bachelor studies, I basically started with playing around with Bitcoin wallets. And that's when I met Alessandro, our co-founder as well. And we've sort of built like one of the first Bitcoin Lightning clients that was able to pay through NFC. So you were able to pay your coffee with NFC payment. So that's how I started out with Web3. And ever since then, I've been researching different aspects of it.
Yep. Talking about Bitcoin and early days, I was just looking at you. You might have seen that the new iPhone is released.
Yep.
And if you wanted to buy iPhone 3 by paying by Bitcoin, you would have to pay 260,000 Bitcoin. That was the first iPhone 3. And if you wanted to buy today's iPhone and you wanted to pay by Bitcoin, it would be 0.007
Crazy.
of a one Bitcoin. So that's how life has changed in the last few
Exactly.
years. But yeah, look, it's an absolute pleasure and honor to have you. I mean, I also started it with gaming as gaming got me interested in computers or computer science, and that's what
Nice.
we learned. Yeah, let's talk a bit about Acurast. So what problem do you guys solve currently at Acurast?
So what problem do we solve? So today there's a huge centralization of compute on planet Earth. So we have huge data centers owned by around 5 companies. I don't have to mention the names. Everybody knows them. It's big tech, right? Whether it be from China or from the US. So that's one huge problem that we have because it sort of monopolizes the pricing, it monopolizes the data, and it can be misused along the way. And also lots of data breaches happen. So I think this is one of the main issues that we address with Acurast, where we have confidential and verifiable compute that is in the hands of everybody.
That's very interesting. It's like I understand the reality of few big tech companies like part of the Magnificent Seven of US and 3 companies in China pretty much control or own all the data centers around the world. But then you get economies of scale. How do you tackle that as a decentralized compute company?
All thanks to the progress in chip making, we can make that happen because TSMC sort of pushes the boundaries there. If I want to mention a company specifically, or in general, smartphone computing is really pushing the boundaries of how much compute you can get out of how much energy you invest. So there's a factor of 50 that we actually can increase in efficiency, and also in terms of cost, we can cut down drastically. So if you buy a smartphone with compare it to a server that has the same RAM and CPU power, you actually have a cost associated with it that is like factor of 7. So if you buy like a Pixel 6 or 7, then you buy it for $600 new. If you upcycle it, you can buy it for $50 if something is broken, fix it. And then essentially like that, you have different economies of scale at play. And if you decentralize that and crowdsource it, then that's when you have Acurast.
Yep. In the gaming world, this has been like since you come from gaming and I come from a gaming background, we all built our own PCs back in the day,
Yeah.
bought the NVIDIA gaming
Mining rigs.
gaming cards, and then the same gaming GPUs were used for whether it was for mining or training AI models or things like that. So it's like in theory, it should be that. And I know there have been companies that have tried to address this, that use decentralized compute power of gaming PCs around the world, that no one, people game a lot. Like, they might game 5 hours, 8 hours, 12 hours a day, but then the remaining 12 hours, the GPU is lying around and that infrastructure is lying around. And when you include hundreds of millions of gamers around the world, there is a lot of compute lying around at any time in the world that could be potentially be used. Why hasn't it materialized? Why isn't a solution for this sort of a thing materialized so far?
I mean, this perfectly fits into our story actually, because we know that we are aware of all these players, but the main issue with these players is that they cannot really verify if the hardware really exists. I mean, of course, there's different algorithms that try to achieve that with randomness sampling and all sorts of fancy stuff. But at the end of the day, you A, cannot verify that the hardware exists, and B, you might not want to trust the operator, right? So if you have anything that is slightly confidential or gives somebody an edge over your business, then you don't want to trust somebody else. So what we do is we basically bootstrap a trusted execution environment inside of these phones. That, of course, depends on the individual OEM that produced it. So each architecture of these phones is different.
Yeah.
And you also have different securities attached to that. But if you take like a modern day Google Pixel phone, you have a very high level of security that can bootstrap from within that co-processor. That's the difference, because we can also verify that this chip exists at a specific point in time, has been produced, and we can encrypt it end to end. So confidentiality and verifiability really is the thing there. Of course, you cannot compete with an NH100 in terms of the GPU performance, but if you look for trust, security, and verifiability, then you will definitely look into Acurast.
How does it all work, and who are your main clients?
How does it all work? Well, that's a broad question.
like a simple question. We'll be here for 3 days.
So let me start in the beginning with the silicon.
With zeros and ones, yes.
So there's a transistor. No. Essentially what happens is that you have processors in the network, as you can see in my background.
Yes.
People around the globe with different phones that either fully dedicate these phones or install an app and it runs in the background. That's on the iOS side, because we cannot fully lock it. So that's the supply side. And then on the demand side, that's why we need a chain to effectively broadcast this compute, that it's available, right? These resources, and then schedule and match it, all the demand side to that compute. And on the demand side, you can then define a job, which is essentially your code that is then packaged and stored decentralized. You can also encrypt it with the public key of the processors, which means that everything is end-to-end encrypted. You can encrypt your job. It will be fetched by the appropriate processors, executed. And that's in a nutshell how it works on a technical level. And of course, on the developer side, we're working day and night to make it as easy as possible and as easy as it is with the centralized clouds. Of course, we are not there yet, but that's our main trajectory.
Once you have this decentralized cloud, do you feel like there would be a certain particular niches or industries that would adopt it before others?
We already have. That's why we're speaking together today, because we already have Web3 clients many years already. And that's how actually the project got initiated as well, because we don't really have a way to build price feeds in a really trustless manner. I know the word trustless is very overburdened in blockchains and Web3, but I think it's the perfect way to describe how we do it. Because as mentioned before, we leverage this decentralized confidential compute to fetch prices, for example, in a consortium of these processors. So not just one, but many. And then you can really do that in a almost real-time manner and deliver these prices on demand. So that's one of the demand side things that we cover. And the other is bridging. So in order to be interoperable with other chains, we very early on did interoperability solutions to and from other chains. So we are very blue ocean approach with that regard, because we think you need to move wherever the demand side is and not build your own walled garden.
Yes.
So that's interoperability side. And then now, as we had the public sale on CoinList, we saw a huge demand spike in Web2, which means web scraping, VPN proxy, which is more and more rising with every AI startup that comes out of SF, because everybody needs some residential IPs to scrape their stuff, right?
Yes.
So that's also a huge asset that we have in our network, all these IPs and compute in combination.
Yeah. What are you seeing on the LLM side of things? Is there still a lot of demand for training LLMs, or is that slowing down a bit now?
I mean, training an LLM is a really hard problem. In our network, we are more on the inference side. So if you
Okay,
want
yes.
to have a
That's why you said
confidential,
NH100 and not 200s or all those chips.
exactly. I mean, I think we pretty quickly realized that we are more in the inference side, and also tested, of course, different LLMs. There's even a tutorial on that. And we work with different ecosystem partners to make that a reality as well. But as you can imagine, these are also startups that are sometimes just figuring it out, but we are pushing that further nevertheless. So also from our side, we see also from the community demand to do that, like running confidential LLM, which is also, I think, actually a perfect use case looking forward to the agentic AI movement, right?
Yes.
Everybody talks about it right now. Not many people use agents, but I think it will be 1-2 years, and then it will be just agents running all over Acurast, personal ones, pricing, feeds for booking.com. I don't know, all sorts of stuff.
Yeah. How can you explain inferencing in like simple terms to someone? What is inferencing?
I would say if you have a specific question to ChatGPT, the moment you ask that question, it is being sent to a server, and that is when inference happens. So basically, you run a query through an LLM and get a reply. That's basically inference. So it's just nothing else than a reply to one of your questions that you had, or a prompt. I would say that's like in a nutshell.
Yeah. Fantastic. That does make a lot of sense. Talking about the agentic AI side of thing, I feel like there has been a lot of promise around AI agents. Are we just calling like a workflow that is stringed together as an agent, or is there supposed to be more to it?
Oh man,
Yes.
why did I mention the agentic AI? Jesus. So let me start with another thing. I was at a conference a couple days ago at a keynote where a professor basically analyzed a paper where people from computer vision came to machine learning and said, or AI, let's put it AI. And they used a model to analyze whether or not encrypted traffic is from a VPN or not. And they didn't know that their analysis, basically, their LLM was just using packet headers, PCAP headers, to analyze yes or no if it's VPN traffic or not, which you could have done with a 6-step decision tree with 2 levels. So I think some of the problems that we address nowadays are actually like
There's you are 100% right. It's like, sorry to interrupt, but I feel like there is
no
so
problem.
much wastage of electricity, resources, and compute and everything because people are asking such simple things to LLMs that should not
Yes.
be asked on an ongoing basis. And people are asking it
Yes.
be the calculator when it's not supposed to be the calculator, as simple as that. But same thing as you said. And that's why I mentioned about, is it just like a workflow, a set of something a simple algorithm could do and those agents now, because they do this, then yes, if not, then do this. That's what an agent is kind of in my way.
I mean, I was at MIT a couple of weeks ago, and it was super interesting, like seeing the bleeding edge of research and sort of practice clashing together and discussing exactly this question. So There was one person from a crypto project that basically said, hey, is anyone even using these agents? Why are we talking about agents? Like there's nobody using these agents. But I think it's like practice colluding with research and sort of VC funding here, right? So we have projects igniting something new that might be used in the future and people that build nowadays. So we have people using nowadays just LLMs, but not agents per se. But there are people building towards a future where you can, or researching also on the academic side, how you can build these agents. And I think one thing that is really specific to agents is that they're autonomous, just a piece of code that is sort of autonomously working. Exactly.
Yeah, definitely.
There's definitely a better definition.
But we always had bots and things that were autonomous. It's like we had the crawlers, search engines, crawlers, and
Now it's an agent.
now it's an agent, no longer a bot.
I mean, terminology is crazy nowadays also with AI. I mean, they say AI, but they actually mean a rule-based engine or an MLM, machine learning model. So everything now is AI and agent. So if it's a bot, it's an agent. We just have to accept it.
Yes, that's fine. That's all good. Can you explain like distributed agent indexing?
So the MIT Nanda project is where we participate is really about the future envisioning of the DNS system, because the DNS system will not really scale well if we have billions and trillions of agents that try to exchange information, if everything has to go through like centralized points of information and trust. That's why we have to sort of build a quilt that does that. And in centralized indexing, you might imagine one big library that has all the information. You always have to go to that library to get the book and the index of the books. But with distributed indexing, every person in the city keeps a few books at home. You have a distributed index where you can ask person A where this shard of books is and then go from there. So that's what Acurast does. And distributed indexing is that it turns smartphones into librarians for AI agents. Let's put it this way. That might be an analogy you can use.
Yeah. Do you have an example of what type of tasks it would do or it would be used to do?
So let's say you have a travel coming up to Korea Blockchain Week and you want to plan side events, book something with a good location, and then also maybe in the future automatically book some meetings with people. Because I think that one we cannot cover really yet. Then you would have one agent that is best specialized on finding accommodation, one specialized on structuring the planning, and then sort of subtasking other agents. And this communication from agent to agent, we can guardrail with these distributed indexes where you don't have to ask just point A where all these agents are, but you can ask another agent and he will give you cryptographic proof and point to a specific address, for example.
That's very interesting. You know, when people think about things such as AI and computing, what is something that you know that most people don't think about or don't know about?
Many things, I guess. I think many people don't realize that LLMs always have a probabilistic element. So I think people that try to understand AI should really start with computer science in the beginning. And I don't mean that like in a disrespectful way, or I don't want to sound like an asshole. So I just mean like they should start with what is a probability, what is also encryption, because there you also have this probabilistic elements to it. So what does it mean if something is a bit random, right? And how is randomness sourced? Computer science. So if you can answer these questions and then go towards these things as how does an LLM actually formulate the reply and what is the difference to a machine learning model? I think these are things that people are still not aware of in the broader sense. And is also why they are misused in terms of their technical deployment and implementation quite often. As we can see with chatbots, for example, going rogue, where chatbots give some promises and then they have to actually comply to these promises because the chatbot has given this information out, for example, on pricing. So just one example, if you understand more or less how these models work, you can sort of backtrack where the mistake could have happened. I think that's one thing. Another thing that people are not aware of, which is not directly tied to AI, but is interesting to me, is quantum computing. How many billions of dollars are invested on that end. And that's a whole nother box that we could open and would fill another hour.
Absolutely. Absolutely. How I see is at AI is approximating to the nearest answer, but we are getting so much processing power and electricity and juice in it that it's getting it right most of the time. And quantum computing is getting multiple answers right at all times. That's how I see those two.
Yeah.
Yes.
Yeah. I mean, in the future, definitely. Now it's a lot of error
Yes.
problem. I think I spent way too much time on that to try to figure out who is not BSing in terms of quantum computing. And it's really a hard topic. You almost need a physics degree to
Exactly.
basically challenge it and figure it out. And I think with AI, if you have a solid understanding of computer science and math, you can figure out a bit readily.
Yes, absolutely. I agree. It's like I just cannot wrap my head around the concepts of quantum computing because we always think of two states, 0 and 1, and not the third state, which can be both 0 and 1 at the same time, which is something I wrap my head around. And it's like, I don't know how it's
Very
I get
abstract.
there. It is so abstract that, yeah, I think we'll have to have another conversation on that.
Yes, we should.
Yeah, coming back to Acurast, as you scale it and as it grows and as adoption grows, what do you think would be like the biggest technical challenge you will face in future?
Technical challenge. It's good that we're an engineering driven team. So 90% of our team are engineers. So we won't have problems in facing these challenges because we do every day. So that's that thing. But I think on the technical side, it will be the clustering is straightforward, meaning that you can chain together hundreds of phones via USB-C or Thunderbolt or any type of connection. But then distributing these workloads, I mean, distributed computing has been a research topic for, I don't know, as many, probably older than I am. So
Yeah.
I think there are some hidden challenges there in distributing workloads. But when we reach that stage, I mean, we already have the funds now and we'll have then to research that in depth and are already doing some research projects in that regard, except, yeah, other challenges. It's always hard to say, to be honest. There's always something waiting tomorrow already.
Oh, absolutely. I was just thinking everything.
I have another one, which is also one of my PhD research topics was multi-party computation and distributed key generation and all that stuff, where you can do like encrypted compute on encryption or encrypted data. So this is one thing that I'm really passionate about as well, because if you would be able to add another layer of protection on the already very protected trusted execution environment setup, then you would have basically fully confidential, like double protected compute. So I think this would be another research topic. But on the engineering side, I mean, there's always a lot of stuff. If you do networking, the internet is always breaking down. So there's always something to fix.
In fact, we had to connect with different Wi-Fi accounts and stuff. We had to change our networks before we connected because we are so far.
Now it's pretty good.
And so now it's pretty good. Yeah. Yeah. I had a question around Moore's law and how things keep getting faster and cheaper, and you know how the speed of tech, how it keeps changing. Does it affect you guys, and how does it affect you?
It's a very good question. So Moore's law has been postulated many years ago and is sort of coming to a end, we could all say, and we would argue. It means that basically the transistor count is doubling every year, which means exponential growth, right? And exponential progress in computing power.
6 nanometers or something. How can we go?
Exactly. So I think they'll reach the atom level right now. And if you go into the manufacturing process of these chips, it's almost like magic where they shoot like lasers at plasma with multiple thousand times a second to just like merge the silicon on the transistor. Reach like a miniaturization point that we now have to rethink Moore's law. And what ARM and many others argue is that we have a new law that is performance per watt, which is what I argued before already, that we actually need to look at how much compute do I get for how much power that I invest. So this is like the new paradigm. And this completely plays into our storybook because with smartphones, they're super efficient with regards to performance per watt. What also plays into our storybook is that phones get always the most bleeding edge chips and they get stronger and more powerful by the year. And more phones are being sold every year, meaning that like our compute resource pool is just growing every day, basically.
Exponentially every year. There'll be so many more older phones coming off the market. What do you feel is the hardest challenge for decentralized physical infrastructure?
I think DePIN has the same problem that many DeFi projects have, that many lending protocols have, is just the demand side to have that organically grown. They look always for me, the whole scene is almost like a bit cannibalistic. Everybody acts like it's very open and collaborative. Of course, our partners are like that, but the rest of the scene is a bit difficult to work with. But anyways, the DePIN especially, since it is like an infrastructure, it's almost some that a government should provide. So you have to do like a very fair and democratic way in building the infrastructure. And then at the same time, making a UX for the developer and institutions as good as possible. So they also want to onboard onto that. So I think that's the biggest challenge of DePIN. And also, if you have to argue too much for why you should use a DePIN, then you might not need it.
Yes.
So I think that's one thing that, I mean, I'm not saying that's a bad thing. It happens to everyone, to people that are just like stuck in this idea. So I think that's a challenge.
Absolutely. Um, my next question is around, I just have 2 or 3 more questions around what's your next milestone for Acurast?
Our next milestone is definitely TG and mainnet launch. I cannot divulge any information on that, of course, as you can imagine. But as soon as we have like final dates and decisions, we will communicate them accordingly.
Yeah.
So that's what we are working on now, full time, full blast. And the next milestone is as well Korea Blockchain Week will be there. Other events in September.
Maybe token end of September, early October.
Exactly. Yes.
Definitely. And on the technical side, do you guys have like a North Star? So this is a concept from back in the days in Web2 startups as well, that, startups have like a North Star that for Airbnb, it might be the number of beds, nights booked, or, Facebook would be daily active users, whatever. So every startup has a different North Star that you get that number right, then everything else is sorted. Is it number of processors linked together, amount of power used, anything? I don't know what it might be, but is there like a key metric or a usage metric that you target?
Very good question as well. We don't have like a specific metric. The DePIN is so complex in terms of all of its parameters. We could say a number of processors, but then you have to really look at the benchmark of these processors. So how
Yes.
much CPU and RAM do they actually have? So all these things are very relevant. Then number of transactions is like secondary if you just have spam.
That's what I get to see is like, it's
Yeah.
how do you remove the spam and the noise from the real adoption?
Exactly. So we already built like with enterprises. As of today, I cannot mention any names, but we built like viable business cases with various enterprises right now. So that traffic is actually what is valuable, right? Because it will drive the value in the mainnet as well, because it will be real world usage. So that's what we are all excited about, because we come from Web2, Web3 developing for a lot of projects. Actually, I would say not ARR only per se, but in link to the on-chain activity. So there is a metric, but I cannot say a number.
That makes a lot of sense. And what's on your roadmap after DGE? It could be in like 12 months, 18 months, anything over 2, 3 years is too hard in our to look at. But yeah, what's on the roadmap?
On the roadmap, we also have codename Cargo, which basically is like compute containers, so that you don't have to retrofit your code to fit into Acurast, which now you can use Node.js, Python, and then to WebAssembly, but still you have to do maybe some modifications as of today. But in the future, you can just use containers to modularize your stuff, or just get your Docker container and run it. That will give a huge boost in developer experience. Then the second thing is these clusters that I mentioned, where you have hundreds and thousands of phones that you can look at one unit. And then we will have different economic strategies on how to incentivize stakeholders to include their existing business model already. And then also like futures. That means like you could say, I want to buy compute resources in 10 months. So I think that will really build like an alternative to centralized clouds if we have all these developments being done.
Amazing. That's very cool. And in order to achieve all of these things and your roadmap, do you guys have asked, are you guys looking for anything in particular? Are you guys looking at funding? Are you guys looking at raising capital, partnerships, anything? Feel free to share with the community. That's sort of final question.
Fundraising, we're fine. We concluded the CoinList sale. So now we are really just looking for strategic partnerships that really want to use ours and the compute, bandwidth, storage in our network to build out use cases. So that's what we look for, essentially.
That's that's amazing. So that means you guys are looking for more builders, developers,
Exactly.
projects.
Your audience. Yeah.
How else do you attract builders? Do you guys do hackathons? Do you guys give out grants or any other things you guys
Sure.
be doing? Feel free to share as well.
We will do grants. We will do hackathons, but as of now, we have to say our network already was sufficient to attract enough potential users. But of course, on the community side, there's always more we will do. Like after TG, this will be, I would say, not the sole focus, of course, but for me, definitely one of the key focuses to onboard as many builders as possible.
Amazing. That's fantastic. And what I'll do is I'll leave links to everything so people can reach out, connect with you guys, find out more about what you guys are building and doing in this.
Perfect.
Thank you so much, Christian, for your time.
Thank you, Sam.
Absolute
Pleasure.
talking with you.
Likewise.
Thank you so much for tuning in and listening or watching this episode of the Web3 with Sam Kamani podcast. By now, you know the drill. Leave a comment or share this episode with a friend and leave a review. I would love to hear from you. So that's why my DMs are open. Reach out to me, especially if you are a founder building a product in Web3. Then I would love to hear from you. What are your challenges? Is there anything that I can help you or my community can help you with? Thank you once again and wish you best of luck in building your startup or your project.